Hello students, I hope you all are fine. I am Dr. Tanmay Vishwas and welcome you all in my channel Chemistry the Mystery of Molecule. So today we will discuss an exceptional reaction related to aromatic electrophilic substitution, that is a field cat reaction, means both alkylation and acylation. So this is a short video. Here we will discuss the formylation of phenolic derivative using tin reagent. Okay, this is a different thing. And here we are taking formaldehyde as a formylation reagent. This look little odd. I believe generally we have taken previously, I have discussed formylation using formal chloride. Formylation using formal chloride. So in case of acid chloride, if it is not stable, means formic acid chloride, then carbon monoxide HCl. So all that is we have taken the acid derivatives. Okay, but here we are not going to use any acid derivative. So this is a different thing. Lots of conceptual clarity is essential, I believe. And at the end, I will provide a MCQ. Okay, what do I mean? I will provide a MCQ based on this understanding, because it is true that directly this thing will not come, but this knowledge is essential. But how, as an examiner, if you consider me as your teacher, how can I make a MCQ based on this understanding? I will provide that MCQ also, such that you are little prepared for future exams. Okay, so let's start. So as you can see, this is a okay. Before going to details, what today's lecture will cover. Today's lecture will cover the basic idea. Why ortho-selectivity? Because it's an ortho-functionalization. Role of formaldehyde, mechanism, and which one is oxidized and reduced. This is an important question, because formaldehyde derivative we are getting formal group. So which one is oxidized, which one is reducing, how? This is an important thing to be learned. Okay, so let's start. So before going to details, if you really like my teaching, please help my channel to grow. Let's start this. So this is an ortho-formylation of phenolic compound. So this part, I guess you keep it in mind. First of all, what is mean by ortho-formylation? Ortho position, aldehyde group, introduction. Fine. Why I am saying phenolic compound? Because see, phenol are actually electron releasing substrate. Electron releasing substrate or electron donating substrate, whatever you say. How this? And even under alkaline condition, see, this is an amine, means basic medium. What it can produce? It can produce O minus N, better to say NR4 plus. Okay, so no, not NR4, NR3H plus, because this proton is abstracted this. So this electron is donated in this way. Ortho, so other canonical forms are possible. So in this way electron is deleted. So this means it's an electron rich nucleus. So electron rich, that is one of the important points, it is essential. Now a simple question you may ask that, sir, if you mix tributylamine means trialkylamine and phenol, is it sufficiently strong basic to abstract this proton? No. But why this abstraction in this case we are taking? Because there is one reagent, that is stannous chloride. Let me give you the details. What is the role of stannous chloride? See, stannous not, it is stannic chloride. Okay, in stannic chloride tin is in +4 oxidation state. So SnCl4. So tin is in +4 oxidation state. So it's a strong Lewis acid. Okay, strong Lewis acid. Consequently, what happens if you put SnCl4? This will go and coordinate with this. So what it will result? It will result this O, this is H, partial positive charge will be generated on oxygen because of donation, and partial negative charge will be generated on tin. Or better to say, we can write this thing in this way also, that's not wrong. Tin is in +1 because it is donated this electron. Sorry, oxygen is plus, this is minus. Now what is the meaning of this? This coordination increases the acidity. So acidity increases. Previously it was not able to abstract this proton, but right now this can abstract this proton. That is the interesting point of this. So now if you put this trialkyl amine, here butyl, this capable to abstract this and it will be neutralized. So ultimately what we made this reagent. Okay. So actually minus charge is here, it is a coordination, better to say. So what is the role? SnCl2 is actually stabilizing the charge density here. Because you can say that, sir, why should we take this much of why should we complicate the story this much? We can directly take sodium phenoxide and do. I agree, that's true. But keep it in mind that in later stage also you need a Lewis acidic center for the formylation. So one reagent performing this two. Second, instead of sodium phenolate, it is better to use phenol and tributyl because milder reaction. Always milder reaction conditions are appreciated. Okay, easy to handle. So what happened in next stage? So this is the team thing. So formaldehyde. You can see if you add formaldehyde, HCHO, what it can do? Formaldehyde as an oxygen. This is oxygen can act as a Lewis base and release its electron to tin 4. So what will be the expected structure of the product? So this is oxygen, this is silicon, and let me draw it here. So let me draw the ultimate structure. This is the oxygen, double bond CH2. So in this way, okay. So in this way, donation is possible. Okay. By the way, one thing I made mistake is when this will be minus, means it is a minus, when it donates, one chloride will leave, and ultimately it is, because see, by charge this is SlCl4. Okay, you can write in this way for your better understanding. So if you put phenoxide, what is expected? It will attack, means first it will attack and it will leave in the beginning stage. In the early stage it will leave and ultimately result in PHOSiCl3. Ultimately charge is balanced, coordination also balanced. Okay, so I forget to mention that thing. So it should be SnCl3. Please correct yourself. Fine. Now see one thing, that this is the methyl. See the word I have told in the previous time. Ortho-formylation means ortho-selectivity. So selective ortho. Why ortho-selectivity? Because see right now this is 1, 2, 3, 4, 5, 6. So if the reaction happens from ortho 6 member ring formation possible, number 1 point. So number 1 point, 6 member ring formation. What is the number 2 point? Let's, for argument, if you consider that para, so this must be, this is 6, this is 7, this is 8. So first of all, H member ring not conformation oriented. Conformation orientation is far apart, this para and this, but these ortho and this is too closer. Okay, that's why. So what is the role of tin? Role of SN is ortho-chelation. This type of concept you have already observed in case of butyl lithium reactivity, directed orthometallation. Similar type of activity is observed because of this group and ortho reactivity. Okay, you please visit if you have any confusion about the concept. Now, so this we are understood fine. This is, so what happens that this negative charge, so what happens, it pushes here, this goes and attack and it goes. Okay, tin can accept electron because of energetically vacant d orbitals. So what is the consequence? This consequence is so this methyl group remain as it is. This is O minus, this is SnCl3. Here also O minus will form a bond and okay. So this is, and negative charge is here, here CH2, and there is a new bond formation. New bond formation means this carbon-carbon bond formation and one hydrogen is here. Okay. So what is the instant reaction of this consequence? So see, in this case aromaticity is gone. Okay. So fine. But one thing, as I told, O minus attached to this, then you may think that O minus attached to this, you may think that why this Cl is not leaving. You may leave it because you may remove one Cl, no problem, that's not wrong. But another thing, in next stage you will understand this Cl actually once come and coordinate with this. I'll explain. So what is expected, that this proton will be abstracted in the medium. Who can abstract? Tributyl amine base is there, and the driving force is aromaticity. Okay, I made mistake, there should be a double bond, and this negative charge is expected to be neutralized. And by the way, one important thing is that, so it will come and it will open. So ultimately what is the thing we are getting? We are getting this. This is methyl, this CH2O SnCl3. Now you can, I guess you can understand. So this is O minus. So it can coordinate or not depending on the situation, doesn't matter. Okay. In next stage what happens? That is interesting. See, according to this, if reaction follow this pathway and get hydrolyzed, means this will abstract one another proton and ultimately it will convert it into phenol. So what is expected, we can get, if you hydrolyze this bond, this tin and oxygen, so hydrolyze means OH will be attached to here, hydrogen will be attached to it. It is expected like that. So what is the product expected? This is OH. So this is CH2OH. This is methyl, as it is everything. So this is expected. If no redox process occur, why I told the redox, which one is oxidized and reduced? See, formaldehyde, actually this is a paraformaldehyde, polymer of formaldehyde, because this is taken because formaldehyde is a gas, but this is a solid. Okay. So in this case, if you take this formaldehyde HCHO, it will be reduced. This part will be reduced 1 unit. This, so we will not expect, we don't expect that we will get directly this alcohol. No, not possible. But what can happen, that how, the next question is how we are getting aldehyde. So now from alcohol to, if we want to go aldehyde, then some oxidation is essential. Then actually this step is not happening. So this hydrolysis is not happening. Okay. So now some oxidation happens. For that case, formaldehyde plays the role. How? This formaldehyde again coordinates to tin. So let's draw the structure. This is OH, this is CH2, OSN, or we can write it in a little better way. CH2O SnCl3. Now another molecule of formaldehyde. This is the interesting part. Please look at this carefully. CH2 double bond O. Why? This formaldehyde will also coordinate to tin. Possible. Tin can expand this coordination. Now, see what can happen. This, instead of 2, 1 hydrogen is here. So this is O minus. Okay, actually this is a minus. I have not mentioned this is a minus thing. Fine. So actually it is neutralized, that's why, but actually this is a minus. Okay. Because one chloride is left, that's why tin is neutralized. So what can happen? This lone pair, better I should represent this is in this way, lone pair. It pushes, this hydride will come here and it will go there. So what is the product? Look at very much carefully. One similar reaction you have already read. I suggest you please try to remember what similar reaction you have read regarding this. So this is actually CH2, one hydrogen came, CH3, double bond became single bond, O, Si, Cl3. You may consider that, okay, there should be a coordination, fine, but after double bond formation, this coordination becomes weaker. Okay, so this Cl3. Now, remove the coordination. Okay, so what is this? So this is nothing but if you put water, means at the end hydrolyze this is actually a methanol plus SiCl3OH, this reagent plus this. So now look at very much carefully. We have taken formaldehyde derivative. Ultimately we expected to get alcohol, and we have reacted this alcohol with an aldehyde, and that's why this alcohol part, this part got oxidized. So somebody needs to be reduced. So this reduced, you can say, to methanol derivative. Methanol derivative. Okay, that is the interesting one. You have read already such type of reaction, that is Cannizzaro reaction. I have made 4 videos about this Cannizzaro reaction. Please visit if you have any confusion. Basic concept, this cross Cannizzaro, ester formation. So this. Now, what is that? Role of formaldehyde is 2 roles. So formaldehyde is playing 2 roles. Role number 1 as a electrophile. Okay. Role number 2, it is as a oxidizing agent. Oxidizing agent. So if it oxidizes someone, then it's reduced. Now question: why this redox part, means oxidation reduction happening? What is the stability? See, formaldehyde is electrophilic reagent, as I told, electron deficient. Compared to this alcohol, this aldehyde is more stable. Why? See, it is electron rich, donation is possible from here and acceptance possible. So this is a conjugated system. So this is a conjugated system. That is the reason it is stable. And compared to formaldehyde, electron deficient, this methanol derivative is more stable. Second point is silicon oxygen. At the end product, this is a silicon oxygen bond. So this oxygen can delocalize its lone pair to the vacant d orbital of silicon. So ultimately everybody is stabilized. So that is the reason of its oxidation as well as reduction. So this, so we have discussed all the part regarding mechanistic thing. So if I make a summary of this mechanism, what happening? First of all, this is creating an anion which increases the electron density in the benzene ring. That's why it acts as an electrophile to attack. Second step, what happened after electrophilic attack? It resulted in alcohol derivative formation. These alcohol derivative undergo Cannizzaro type of reaction by the presence of this tin reagent, because it helps with coordination. It provides coordination site, and that's why one part is reduced, means, and this formaldehyde is reduced, and this part is oxidized, and consequently it resulted in final aldehyde derivative. Okay. Now, one interesting thing of what is the role of this methyl? Actually, it do not have any role. By the way, you may think that, sir, this is blocked, that's why reaction is happening at this side. Agree. But actually not. If it is blocked, then we can have some product. You may think that some product we can expect. This is the CH3. In case of Reimartiman angular methyl group introduction concept, just remember, we can have some product about this CH2OSN, this, but we are not getting those things. So it is not happening in this way. This is an ortho-selective. That's why I have told ortho-formylation. Okay. So now I will discuss an MCQ based on this concept. I believe you have understood the concept. Now discuss the MCQ. Okay. Let's discuss this MCQ. Now see, a question may be constructed for your exam theme. So exam means, in this you can consider CSIR, NET, GATE, or IIT JAM type of exam for that. So this is the reaction, what product. So they can they can remove this solid part. So one question you can even consider. So what is the structure of the product? Options are given: A, B, C, D, E, F. Means I have given 6. Generally 4 are given. So 4 example could be withdrawn from among 6 examples. Okay. So as you have read this video, you know the product is this. But consider that you don't know, you haven't read this. So how will you be confused? So this reaction will definitely think product will be either this or this. How? Sometimes people try a guess. What? oh, these two means a closer type of understanding this. It is expected that among these two one product. Let's see. Oh, no hydrolysis is given, so it is expected you will write this product. No, it is not. That's why we learn the thing properly. Otherwise, we can do mistake. Okay. And here paraformaldehyde, no equivalence is written, so you can't ensure that reaction will stop here. Actually, this is the intermediate, and it will undergo from here to here because this is the product. One option. One way you can do mistake. Second mistake. Somebody can think, okay, I have read Raymond-Timan reaction, angular methyl group introduction. This is formaldehyde, similar type of concept. Okay, so what can happen? Para position substitution. So they can think that okay, this could be the product. You end up the mistake. Okay, somebody can think, okay, fine. This after this, what can happen? After aromatic electrophilic substitution, para position. This is CH3. This is CH2OSI. This is double bond. This. Then what can happen? That under the reaction condition, this methyl can migrate at this position. So we can check, we can get methyl migration. Okay. Either you can get aldehyde or alcohol, whatever, but you will think that this is more logical. Both. Is it this answer or not? So lots of confusions are there. That's why it is always best to learn what is the exact structure. Okay. So this is the end of this discussion. I thank you all for your patience to watch this video. If you really like my teaching, please help my channel, promote my channel. And how can you do that? First of all, subscribe my channel Chemistry the Mystery of Polygon. Please press the notification bar for all videos because I prefer to upload videos on a regular basis. Secondly, share this video among your friends so that many people could be benefited from my effort. And most importantly, please like this video and make some good comment because it inspires a lot. So thank you again. Don't worry, I'll try to make some good videos for you such that you can learn more. And I always request you, please watch the video completely. Otherwise, I prefer to improve the basic understanding. I believe sometimes it is difficult for you to watch completely 20 minutes video. You can skip little bit, but don't watch the first 2 minutes. Finish. Don't do that because you may miss. Okay, you can see that how a MCQ question can come which can complicate your life. So thank you again. See you in my next video. Till now, stay happy, stay blessed.